Number 4 says 24 people attended a birthday party at Chuck E. Cheese. The ages were as follows, right? So, got a birthday party at Chuck E. Cheese. We got some ages. Okay, the numbers are all random. I see some, little kids there. I see a 3, somebody that's a little bit older, 25. But I want to get a feel for what's the age of most people at this party. It's kind of hard to tell that when the numbers are all randomly mixed up. So we could do a dot plot, right, which is what we've been working on so far. But another way to represent these numbers is through what we call a histogram. And so that's what this is, or what we're going to end up drawing, is what's called a histogram. And so what a histogram does is it shows ranges, right? And so instead of showing every specific point, because that's what a dot plot does, it shows every dot, we just want to know ranges. So for instance, our ranges here are, how many kids were from 0 to 4, or for 5 to 9, 10 to 14. And this is helpful when we're dealing with maybe a larger data set, more numbers. We don't maybe need to know every single age. We just want to know age groups. So kind of, the question of, well, which one do I use, dot plot or histogram? That takes some practice to figure out what story you're trying to tell, because that's all statistics is it's telling a story with numbers, and so you have to figure out what story to tell. But at this point, since we're just learning some of the basics of this stuff, this is already laid out for you. So we're going to make a histogram. You see where it says tally? So that what we're going to do is that, similar to what we did the dot plot, we crossed it off as we went along. I'm going to do kind of a similar thing, but I'm not going to write the number yet because I don't know how many people were in between 0 and 4. So I'm just going to do some tally marks. So I've got 4, I've got 7, I've got 6, I've got 4, 25 and 22, so 25 and 22, 6 and 16, so 6 and 16, 6, 4, 6, so that would be 6, 4, 6. And remember with the tally marks, we count by 5s because it's really easy to count by 5. So when you get to the 5th one, you don't draw a 5th line. We do a slash like that, and that means 5. So we're grouping them in 5s. 3, 7, 7. So we'll do 3, 7, 7. 6, 6, 5. So we'll do 6, 6, 5. 7, 6, 7. So we've got 7, 6, 7. 17, 4, and 7. So 4 and 7. And so it looks like a pattern has definitely emerged here in terms of how many we have in each group. So it looks like for 0 to 4, it looks like we've got 6 kids that are between 0 and 4. 5, 10, and 4 more would be 14. So we've got 14 that are between 5 and 9. Nothing in that box. So that just would be 0. That means we don't have anybody that's in between 10 and 14 years old. 15 through 19 looks like we've got 2. 20 through 24 we've got 1. And 25 through 29 would also be 1. Alright, now as far as kind of setting up my histogram, I'm actually going to use the same categories that they did in the table, right, that's already kind of laid out for me. So the ages are going to be from 0 to 4, from 5 to 9, 10 to 14, 15 to 19, and 20 through 24, and 25 through 29. And then the y-axis is going to represent the frequency, right, which is the number of times that age group appeared. So we're counting, and we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oh, we need to go up to 14. That's our biggest number. So 11, 12, 13, and then 14. And then all we're going to do is just fill in how many we had for each category. So for instance, for the 0 to 4, we had 6 people. So what I'm going to do is that I'm going to go up to 6, and then I'm going to draw a column there. For 5 to 9, and by the way, you notice that these bars are going to be touching. There's not going to be a gap. So for my 5 to 9, which was 14 people, I'm going to go straight up from there up to 14. Now I just said there's no gaps. Now the difference here would be is that for 10 to 14 there actually is no one there that's from 10 to 14 years old, so we're going to skip that. 15 to 19, that was 2 people. And then 20 through 24, that was 1 person. And then 25 through 29, that was also 1 person as well. And so what I can do, just make this a little more visually interesting here, we'll go back in and kind of color this in a little bit so we can see what's actually happening here. And again, this is just a visual representation of how many people attended this party. By the way, you saw me, I erased it because I had marked over in that 10 to 14 area, and again, nobody was there from 10 to 14. So it should look like that. So there should be a gap there in between 10 and 14. So what this does is that, this real quickly lets me say, okay, well, how old were most people at this party? Well, most people at this party were between 5 and 9, so it looks like a little kid's party, right? Maybe, do we have any outliers here? Right, so maybe we got a couple older brothers, sisters, cousins, or something that were there. Maybe mom, dad. But for the most part, right, we got little kids at the party. So that's really what we wanted to do with this problem, was just set up the histogram. And then there's one other little question down here on the bottom, which says, describe the shape of the graph. Symmetric, skewed right, or skewed left. So what this refers to is it balanced? Do we have a little bit on one side, a little bit on the other, and then most everything in the middle? It's similar to on that first problem when we talked about standard deviation. Something that has a normal distribution has this kind of shape to it, where you've got a little bit on one side, a little bit on the other, and then most is in the middle. So we then want to, if it does have that, then we would say that it would be symmetric. But I don't know that this really looks like that, because it seems like most everyone's piled up on the left. So what we would say is we look at, well, where are the numbers not? Right? If I kind of follow the path here, what ends up being is that the numbers, where there are not a lot of numbers, there's not a lot of numbers on the right side. So this would indicate to us that perhaps this graph is skewed right. Now we have a little test for that, which is that we check to see if the mean and the median, we compare those two numbers. So real quick, we're gonna figure out what the mean is and the median, and that will also help us tell whether which direction this thing is skewed, if it is. So what we're gonna do is we're gonna go back to the calculator real quick. Hopefully you should feel pretty comfortable doing this part of it at this point. Let's clear it out. And what we've got is that we've got, if we take the numbers, and we'll actually need to scroll back up to the top here. And let me clear out so I can actually read this. So we're going to enter in the numbers. And the reason why we had to go back up to the top is that this doesn't tell us, if I just said 6, well, 6 what? Well, that's 6 from 0 to 4. It doesn't tell me the individual points. So if I want to go back to the individual points, I have to go back to the original numbers that they gave me up top there. So it looks like I've got, and typing this in, I'm just going to type it in like I see it. So 3, 4, 7, 6, 7, 6, 4, 25, 22, 25, 22. We hadn't mentioned that, but you see I typed an extra number there. Just scroll back, hit delete, and then you can fix the number there. 6, 16, 6, 4, 6, 3. So 4, 6, 3, and 7, 7, 6, 6, 5, 7, 6. And where do we leave off? 7, 17, and 4, and then 7. And so I've got a total of 24 numbers. Again, I want to make sure that that's actually correct. So if I went back to my original problem it does tell me that I've got a total of 24 people that came to this party. So, or just want to make sure that those numbers are correct, and they are. So let's go to stat calc, one variable stat, same place. And our x bar here is going to be 7.95. So we're just going to round here a little bit. So we'll say approximately 8. We'll do a little squiggly when we round. That means approximately. So the average age here was approximately 8 years old at the party, which makes sense because the biggest group here was 5 to 9. And that's the tallest bar, and 8 is in between 5 and 9, so that should make sense. The median, so if we look to see what the median is, the median, they tell us, is going to be 6. So what ends up happening is that if the mean is greater than the median, then we would say that it's skewed right. So basically that the average and the middle don't match up. So this is so there's two things we could say here, is that it's skewed right because one, we could say that the mean is greater than the median, because the mean is greater than the median. If the mean and, by the way, if the mean and median are equal, that's when it would be symmetric. Or if the mean is less than the median, then that's when it would be skewed left. So if it was mean less than median, that would be skewed left. But in this case, the mean is greater than the median, so it would be skewed right. And the other thing we could say is that most of the data points, if we want to talk about just looking at the picture, so forget doing this part of it, just look at the picture, it looks like where are the points missing? Like, what's causing this to not be balanced? Well, because there's not a lot of data points on the right. You'd almost kind of think that because most of the numbers are on the left, that it would be called skewed left. But what we're actually looking at is that we look at kind of where the tail of this ends up. And this actually is referred to as the tail. And the tail of it's on the right side. So we would say that it's also skewed right. So we could complete our sentence by saying, and because most of the data points are on the left. On the left. Okay. All right, so that finishes up number 4. So I will tell you that number 4 on the right side, that you're going to get the mean and the median are equal. So you should get that the graph is symmetric. So you should get something for number 4 on the right side. You should get something that's balanced like that. All right, so let's go ahead and stop now and try number 4 on the right side.